So let's see today's question. So in the question you are given an array nums and an integer, non-negative integer k. Okay, and you can perform one operation in this is the operation you can perform on that array, and you have to find that after performing that operation any number of times you can uh, do it for any number of times. You have to find the beauty of the array. Okay, now maximum possible beauty of the array. So uh, what is the beauty of array? So beauty of array is defined as the longest length of longest subsequence consisting of equal elements. So what does it means is, first of all, subsequence is an array generated from the original array, okay, by deleting some elements, possibly none, without changing the order of the remaining elements. Like for this array, the one possible subsequence can be 4 1 and 2, other can be 6 and 1, other can be 6 and 2. But yes, 6 4 1 cannot be a subsequence because we are changing the order now. Okay, so these can be subsequence. So now you have to find out the maximum length of a subsequence in which all the elements are equal. Okay, you have to find out that, and you have to maximize this. And what you can do, you can perform an operation on the array. What is that operation? You choose any element at, you can choose any element at most one times. Okay, and you can like replace that element with the num psi minus k to num psi plus k. Like if you choose 4, you can replace 4 from the range uh, 2 to 6. Okay, because 4 minus 2 is 2, k here is 2, and 4 plus 2 is 6. So you can replace 4 from the range 2 to 6. Okay, likewise you can replace 1 from the range 1 to, sorry, minus 1 to 3. So you can do this any number of times. Okay, uh, and you can do this for like for one element you can do this at most once time. Okay, at most one time. And after applying this operation, you have to find out the maximum number of uh, maximum length of a subsequence which is having equal elements. So by this it is like the maximum length of the subsequence, they are trying to say that you have to like find out the maximum number of elements which are equal in the array, which can be equal in the array. Like because it means the same thing. If you are having the maximum number of elements which can be equal in the array, that will form a maximum length of subsequence having equal elements. Okay, so yes, now what can be the possible like solution for it? So obviously you can do it in n square by applying two for loops, like for checking every element. So like what would be the brute force? Let's see first that your intuition says that what you can do, you can like try for every element. Like, can I make this element equal to all elements? Okay, like four, let's say 4. Let's take 4 and we will see that can we make all other elements equal to 4, or how much elements can we make equal to 4, how many maximum elements can we make equal to 4. We will check for that. Then we will check for 6, that how many maximum elements can we make equal to 6 after applying that operation. Okay, now we will check for 1. So likewise what is the range of this? Like uh, its range will be the minimum minus k to maximum plus k. Why it will be that because obviously you can replace 2 with 2 from, you can replace 2 with the elements from the range 2 plus 2, which is 4 and 4 to 0, like in the range 0 to 4. So the element can be equal to 0 also. Okay, and which is the minimum, like the element can't be sorry, my bad. Yeah, the minimum element is 1, so the element at most, at lowest, can be equal to minus 1. Okay, that minus 1 can be a possible answer, that all the elements are equal to minus 1, so therefore you can return that. And the maximum, what could be the answer? 6 plus 2, which is 8. So the range is from minus 1 to 8, which is if we generalize it, which is minimum in the array minus k and maximum in the array plus k. So this is the range that can be like, we can iterate on this range, that is this range that we can make, we will try to make the elements equal to that particular element in that range. Okay, yes, so we will do it likewise. Yeah, but then also it will take n square, because we are doing for like 10 raised to almost 10 raised to 5 elements. We are checking for every element that can be make that element how much can we make that can we make the array's element equal to that element, and if we can make how much array elements can we make equal to it. So that will take a complexity of n square, but to do it in like we can do it in n log n also, applying binary search on it. So what we'll do, we will first calculate the range, obviously, which is min minus k plus max, min minus k to max plus k. Okay, and then for every element in that range, what we'll do, first we will sort this array and we will see that how much elements are greater than or less than equal to uh, that specified thing. Like I will try to first show you that, like let's sort this 1 2 4 and 6. Okay, so you are given you sort this array. Okay, now let's say you are doing it for take uh, how much you are doing it for, let's say uh, take an example like 3. You're doing it for 3. Now you are trying that can we make like how much elements in the array can we make equal to k. So uh, y- like obviously see, you can make 1 equal to 3, right? Because you can replace nums of I from nums of minus k to nums of I plus k. So the range of 1 is uh, from minus 1 to minus 1 to 3. So yes, you can replace 3. Okay, you can make 1 equal to 3. Then similarly you can make 2 equal to 3, because the range of 2 is from 0 to 4. You can make 4 also equal to 3, because the range of 4 is from uh, 2 to 6. But yes, you can't make 6 equal to 3. Okay, 6, because the range of 6 is from 4 to 8. So here you got the thing that you can't make that. Likewise, if there are elements greater than here in this fashion, you can't obviously make those elements also equal to 3, because they are greater than 6. And if we found some element for which we can't make equal to 3, then obviously for the greater elements we can't make it equal to 3. Okay, likewise, if there are elements less than this, like minus 1 and uh, minus 10, minus 20. Okay, if there are elements like this, so you can see let's take example of minus 1. Can we make minus 1 equal to 3? So minus 1, the range for minus 1 is from minus 3 to 1, but we can't make here equal to 3. So if we can't make minus 1 equal to 3, obviously we can't make the lower elements also equal to 3, because they are lower than that, and their range will also not in their range also there will be no 3, because minus 1 is not having that range. So we have to find this, that the least element in this array which satisfy that. Okay, like in this here, in this example, 1 satisfy that, and the maximum also element where 4 satisfy that. So the answer for this will be 3. These three elements can be changed to 3. So for that, the answer will be 3. So like we can do this using binary search. Like we can find the maximum element which is less than 3 plus k. Okay, uh, 3 plus k, so 3 plus k is how much? 5. So we will find the maximum element which is having which is less than or equal to 5. So here we got 4, and also we will find uh, like 3 minus k. We will find the elements which are uh, greater than 3 minus, greater than equal to 3 minus k. 3 minus k is how much? Which is, that is equal to 1. So we will find the elements which are greater than equal to 1. Yes, so we get this. Now we will subtract this like 4, the index of 4 from 1. So we will get the answer 4 minus 1 plus 1. 4 minus 1 plus 1, that is equal to 3. So we get 3 elements like this. So let's try to code it actually. So the range, how much we have decided the range that it could go minimum up to, first we'll sort the array. Okay, so the minimum range could be, minimum is equal to nums of 0 minus k, as it is sorted. So the minimum element will be stored in the first index, and the maximum range could be from nums dot length minus 1 plus k. Okay, yes, this is the range. Now you have to do this for every element. Okay, for int I is equal to min, I is less than equal to max. We are checking that can we make how many elements in the array can be made equal to I. Okay, so for that what we'll do, we will find the left index, which is the elements which are less than equal to nums minus k, nums uh, not nums minus k, I minus k. So if you want to make all the elements equal to I, like how many elements we can make I, if you have to check that, first you will find out the left index. Okay, the elements which is less than, strictly less than I minus k. Okay, so that can't be made that can't be made equal to I. And you will also find the right index, which nums from I plus k. So I plus k plus 1 actually. So these are the elements which are can be made equal to I. Okay, like these contains actually the elements, this also. So we will subtract from R to R, from, like we will subtract L from R. So answer would be math dot maximum of answer comma R minus L plus 1, actually not plus 1, L minus L. So actually this should be written here. Okay, max, here we can write max possible element which can be made equal, can be made to I. Okay, we are finding the index of that, and here the minimum element which can be made equal to I. Yes, and at last we will return the answer. Okay, let's define now we will write the code for the binary search. What we are doing, public int vs int arr. Let's suppose we are taking the name of the variable x. We have to make all the, like we have to find how many elements can we make equal to x. No, actually sorry, how many elements which are less than x, we are finding that in this binary search. Okay, so the range is from start is 0 to end is arr dot length minus 1. Let's initialize that answer index with minus 1. Okay, and yes, while s is less than equal to n, first we'll calculate the mid, and now if arr of mid, this is less than x, what does that means? That yeah, we got a element which is, we have to find in this binary, so that the maximum possible element which is less than x. Okay, so yes, we find an element here which is less than x, so we will mark answer as mid. But yes, we can find more, like we can find the bigger index element also. So what we'll do, we will find for that, so we will just do start is equal to mid plus 1. Okay, but else in the, if it is greater than equal to x, then we don't find this in uh, right, therefore we will go to in the left, and is equal to mid minus 1. At last we will return the answer. Okay, let's try to run this. Okay, what's the error? Okay, there is no semicolon there. Yes, it's working. Let's try to submit it. Yeah, it's accepted. Okay, thank you all for watching.